Greetings and welcome, friends. Today we are going to pass words through a portal into the universe of mathematics. We are going to be translating verbal phrases from the English to the universal language of math, which is wonderful. Math is universal. In fact, like even in terms of some of these satellites we've sent out into space, we've written mathematical communications so that if there were some intelligent life out there, they could determine that we also knew math. And math, being an international and universal language, has actually been able to be simultaneously discovered in the same lifetime by people on different in different countries. All right, like math has been independently discovered by different cultures on different continents because it's innate within our universe. But we, as my speaking English as a math teacher, we need to know how to convert from English words and use these English words to describe the mathematics and vice versa, so that when I have a math equation written on a screen, I can then verbalize that so that everyone else knows what we're talking about. And in order to do that, we jump in with some words that imply math operations. So addition, they gave us a whole bunch here. Added to, plus, sum of, more than, increased by, total of, and, right? If I say a number and two, right? Something like that. I already gave my kids the heads up that sum means addition within parentheses. Subtraction, you could have subtracted from. Right? Minus, the difference of, which means subtract within parentheses. Less than, decreased by, fewer than, take away. All sorts of words that describe that. Multiplication, we're starting to run out of words here. Multiplied by, times, product of, twice. So that literally does not just mean multiplication. That means multiply by 2. Or 2 times something. And then of. Trying to think of how I need an example that I can give you, but it's not coming to me. Nope. Well, we'll see. We'll keep our eyes out for that one. And then division is divided by or quotient of. Now, ones to be careful of is subtraction. The order matters. Okay, these are not commutative, right? 3 minus 2 is not the same as 2 minus 3. And the same thing with division. Order matters, okay? So you've got to be super cautious when translating those things. 2/3 is not equal to 3/2, right? 2/3 is 0.6 repeating, and that is not equal to 1.5. I think you guys agree. All right, so let's jump in here. I hit airplane mode instead of screen capture. Classic Mr. Waddy. All right, all right, airplane mode off. Here we go. All right, so you guys following along, we're on example uno. Write this down, right? Devin's rubbing his eyes. He can hardly believe it. We are on example 1. All right, 8 fewer than 21. It says write the phrase as an expression. So the phrase, this is English, expression is the math. So 8 fewer than something, that means the 8 is being subtracted from something, okay? 8 is being subtracted from 21. They didn't ask us to evaluate, but if they did, what is 21 minus 8? Oh, yeah, 30, I had to think about that too. You could do the trick of what's 21 minus 10 is 11, and then plus the 2 that the 8 was less than 10. Don't you worry about me, none. All right, the product of 30 and 9. Product means multiply of 30 and 9. All right, so notice as I'm reading it, I was writing down those symbols. The product of 30 and 9. And 30 times 9, that's the same as 3 times 9, is 27, times 10, which is 270. They didn't ask for that. They just wanted the expression to be translated. All right, let's keep going. Example 2. Guys, we're doing so great at this. I can't wait for tomorrow, though. Waiting for others to come back first. Writing algebraic expressions. Here we go. Oh, algebraic expressions, friends, Remember, algebraic expressions won't just have numbers and operations, but might also have a value that's represented by a variable, right? Some letter. Those letters can be, I was going to say English, but what are I don't remember. But they also can be Greek letters like phi or all sorts of crazy stuff. Alpha, beta. So let's see. It says 14 more than. So let's see, Devin, what does 14 more than suggest to us? How could I interpret just that part? Plus 14, I like it, because it's 14 being added to something, and then it says 14 more than a number x, so we'll call that x plus 14. Can't simplify that. If I know what x is equal to, I could plug it in and evaluate, but right now I don't. Let's see. Okay. Ooh. Let's see. Puja. A number y minus 75. How would you translate that phrase, you think? Yeah, y and minus is subtract, and 75. Order matters there. And that's it. That's all we got to do for that one. No es más mal, right? El más fácil del mundo. Let's see here. Ooh, can I do this? Oh, I can. Hooray. Let's have you guys quickly try some of these ones on your own. And so that includes you at home, internet friends, playing the home version of Wadi Math. Maybe. All right, so yeah, you guys, so try to write these. Let's see, did I leave enough space for myself? I didn't, did I? All right, so the sum of 18 and 35. I'll walk around. You guys give this a shot. I'll see how you do. Drink some more coffee. Yep, I was completely. All right, let's go. Internet friends, I'm back. Hey. All right. The sum of 18 and 35. Sum, as we will find out, means add with priority, add within parentheses, do this first, add. Okay. But in this case, it doesn't really matter because that's the only operation, so I don't need the parentheses. 6 times 50, right? That's 6 times 50 like that. 25 less than. Make sure you get this order. 25 subtracted from B. All right. Muy importante, mis amigos. There's another pencil sharpener over on the side of the whiteboard. A number x divided by 4. A few ways you could write this. You could write x division sign 4. We'll work away from using this symbol in algebra. I'd probably write that as x over 4 using a fraction bar. But both of those are legitimate. The order matters. You can't do 4 divided by x. The total, what operation is suggested by that? Addition of a number t and 11, so t plus 11. Also, I like to put a little tail on my t like this, so that it doesn't look like a plus sign. Right? Good strat, good strat. 100 decreased by. Ooh. It is subtraction, but 100 is where I start, and then it was decreased by a number k. So yeah, that one's a little trickier catching that order. So let's see. I've been saying this for a while. Here we go. Here we go. But sum and difference. Sum means to add with priority, to add within parentheses. And then the next two things they tell you after the word sum is the numbers that go, all right, that are being added there. And then difference means to subtract within parentheses. All right, and then the first thing they'd give you afterwards would be the number that goes here, and the second thing right there. Let's see, I made up my own examples. Look at clever Mr. Waddy, that mathematician. I called this example 2.5. Example 2.5. I'm so hilarious. It's so accurate, though. It's funny because it's true. It's like partway between examples 2 and 3. That's why it was funny, in case you didn't know. It probably wasn't funny. Oh, no. Ah! There we go. So, look at this. Ooh. All right, 3 times the sum of a number m and 4. Bunch of stuff going on here. All right, so 3 times, and then I hear the word sum. Without hearing anything more, without reading any more, I'm going to put parentheses with a plus sign in the middle of it. Okay? That's only having read up to this point. And then it says of a number m, so the first thing I heard was m, and 4. All right? And if, according to order of operations, the addition would have happened first because it was in parentheses. And that's different than B here, which just says 3 times a number m plus 4. I could have also said 4 more than 3 times a number m, or 4 more than the product of 3 and m, right? All sorts of things. Let's see. Half. What does half mean? Divide by 2. I could write it this way, or I could do 1/2 times something. All right, both ways work. Half the difference, I hear difference, that immediately means subtracting within parentheses. Okay, of 8 and 2. So 8 minus 2. I already had the minus sign there. So either of those would be legitimate. Now this fraction bar, when it's longer like that, it is actually a type of grouping symbol that I could eliminate these parentheses here, and it would still suggest that I have to do the subtraction first, because the fraction bar itself is a grouping symbol. All right, ooh, the square. What does square mean? I have not used that term yet. Squaring something means to raise it to the second power. All right, specifically second power. So the square of the difference, so subtraction within parentheses, and it's being squared. And the difference of a number n and 2. Yeah, those ones be tricky. All right, all right. Now, the benefit of being able to make these simple translations is we can eventually have more words describing more things about the world we live in, and then be able to model our reality with mathematical expressions and equations. So here we go. Example 3. It says the length of Interstate 90 from the west coast to the Beast Coast is 153.5 miles, more than, oh my goodness, guys, this is tricky, more than 2 times the length of Interstate 15 from Southern California to Northern Montana. Okay, let's see if I can figure this out. Let M be the length of Interstate 15. Okay, M. Which expression can you use to represent the length of Interstate 90? Okay, so let's see if we can figure this out. So, all right. Interstate 90 is 153.5 miles more than. So looking at just this part, that means I should be adding 153.5 to something, right? And more than, and then what? 2 times the length. All right, so that's going to be more than 2 times something. And it says the length of, right, Interstate 15 from California to Montana. And that's my variable. Right, that's starting to get tricky when they start combining all of these. Sometimes they give us more information than we need. Notice I never used the number 90 or 15. I guess kind of 1 and 5 showed up there. But right, that was just like extra information. But I had to kind of try to interpret all of these pieces together, and you guys notice that the answer is A, right? There we go. And then, yeah, D was the problem, right? I didn't know if it was going to try to do a switcheroo commutative property. Oh, my goodness. Guys, I just messed up somehow. Oh, dear. I don't know how I did that. I just changed desktops? Oh, no, everything just crashed. No, they didn't. I don't know what happened, but I'm back. It's good to be back, friends. That was scary. I traveled to like a parallel dimension where I didn't know how to do math or work computers. Oh, I hope that never happens again. All right, let's do example 4, the last one. Example 4, we're doing it together. We're learning the math, getting ready for the algebra. Boy. All right. You plant a cypress tree that is 10 inches tall. So that's like the starting value. Each year its height increases by 15. Okay, make a table that shows the height of the tree for 4 years. All right, so let's make a table here, friends. Making tables like I'm a carpenter, except they're more like spreadsheets. All right, so I should have the value of t for my table. I'll have years 0 and 1 and 2 and 3 and 4. And then I'll calculate some stuff. I'll find out my formula here in a minute. And then I'll have the output is its height, which I'll call h. That sounds good. All right. And let's see. So what should my kind of equation be? It starts at 10. So 10 is the starting value. So it's 10 and then plus 15 inches each year. Each year, what type of operation do you think that means? I could say per year. Multiplication. So I'm going to multiply 15 times the time. And time is going to be measured in years. All right. So let's figure these out. So this is going to be 10 plus 15 times 0. That's just 10, right? At year 0, it was the day we bought it. It was 10 inches tall. 10 plus 15 times 1. What's that going to be, guys? 25. Yeah. 15 times 1 is 15 plus 10. 25. All right, 10 plus 15 times 2. Order of operations, I'd multiply first. Well, 15 times 0 is 0, but then 10 plus 0 is still 10. Okay. 15 times 2 is 30, plus 10 is 40. And then let's see, 10 times, 10 plus 15 times 3. 15 times 3 is 45 plus 10. 55. And then let's see, 10 plus 15 times 4. Anyone know 15 times 4? 60. 60 plus 10 is 70. All right, so this represents the height of the tree every year. Also, I want to point this out. This 15 per year notice that once I knew one of these, I could have actually just found each consecutive one by adding 15, right? That's the increase, the amount that it was increasing by. But I think that being able to use a formula is going to be more interesting, more helpful in the future, especially when they say, what is the height after 9 years? Now, in order to do that, I'm going to say the height is equal to 10 plus 15 times, what could I plug in for t? After 9 years, t is going to equal 9. I'm going to just plug 9 in there, right? You guys see why I'm doing that? Right, 15 times the number of years since I bought it. If it's 9 years, I'll just do 15 times 9 and add that to 10, right? If I wanted, I could just keep adding 15, adding 15, adding 15, adding 15. But if, like, this number's starting to get large that I really don't want to make a table for that. Or what if I ask you for the height in 20 years, right? I wouldn't want you to have to make a huge table. So this is all I'd have to do is plug in the 9 for t. 15 times 9, what's that? 90 plus 45, 135. And then add 10 to that. H is equal to 145. And that's measured in inches. Right? That's a little bit tricky, right? A little bit tricky trying to find an expression that represents the height based off of the information they gave us, using a variable that they gave us, and then being able to plug in a number for that variable to then put that model, that mathematical representation of reality, to work. All right, thanks for watching, Internet friends. Have a great day.